Okay, so still using the computer. Hopefully you can see this. If not, I'm going to have to re-record videos. Oh, there goes my keyboard. Perfect. There we go. Still works. So solution sets to simultaneous equations. We've kind of already done this. Today, what we're going to work on is solving systems using the elimination method. Again, these are all things that you should have learned in 8th grade. So you have to go back to those videos that I posted to kind of watch them. But I'm going to mostly talk about how we eliminate. Okay? So this is not the Engage New York way. Listen to that. This is not the Engage New York way. This is Mr. H teaching what Engage New York wants, Mr. H's way. So right now we are learning what's called the elimination method. I know I keep peeking because I can't tell if it's working. So the original system is 2x plus y equals 6. The goal of the elimination method is to have either both x values the same or both y values the same. So in this case, 2x, this is 1x. My goal is to multiply this equation by something to get the same x's. And I'm going to multiply this whole equation by what? Well, by 2. When I multiply the whole equation by 2, both sides, it actually doesn't change the equation, okay? It just makes it equivalent a different way, because remember, we can always factor out and divide out. So my new system is 2x plus y equals 6. And then I distribute to everything. My new equation for this one is 2x minus 6y equals negative 22. And then I'm going to draw a big line. Now I want to solve. Well, what am I going to solve for? Well, if the x's are the same, I want to eliminate them, which means get rid of. So I'm going to solve for y's. Well, how do I eliminate my x's? By using the additive inverse. So I'm going to subtract. 2x minus 2x is 0. I have no x's. 0 x's is an aux. Remember, I don't teach 4-H, so we're not going to have any aux's. Y minus a negative 6. Minus a minus is plus. That leaves me with 7y equals 6 minus a negative 22 is positive 28. I've eliminated the x to get one variable by itself, hence elimination. I've used two properties. I've used the multiplicative property, which is just saying, hey, if I multiply an equation by the whole equation by something, it doesn't really change the equation. It makes it equivalent. Then I've used the additive inverse to eliminate the x's, and now I can use the multiplicative inverse to solve for y. So I already have part of my solution. My y value for this system is 4. Well, how do I go back and find my x? I go back to the one that I didn't change. And I say 2x plus 4 equals 6. I subtract 4, leaves me with 2x equals 2. I divide both sides by 2, x equals 1. My solution is now 1, 4. Can I double check to make sure that works? So I'm going to erase this. Let's substitute in as a check. 2 times 1 plus 4 equals 6. My x is 1 minus 3 times 4 equals negative 11. So 2 times 1 is 2 plus 4 does equal 6. This one checks out. This one, 1 minus 12 equals negative 11. Negative 11 equals negative 11. This one checks out. So my solution is correct using the elimination method. Again, the goal is realizing the reason elimination works is because multiplying an entire equation does not change it. So this time, could we multiply the x by 2? Sure. Could we multiply the y though? Let's do the y. Let's try to eliminate the y's this time. What would I need to multiply this entire equation so that the y's are the same? Well, this is a 3y. We need this to be a 3y. So we multiply this by 3. So my new system is 2x plus 3. And we're trying to eliminate the variable y. So I guessed right. I didn't even read the directions. I should have. So this gives me 2x plus 3y equals 7. And 3x minus 3y equals 1. Now, to eliminate the y's, we're using the additive inverse. Positive and negative. 2x plus 3x is 5x's. 3 plus a negative 3 is 0. 0 y's, oi. We don't have any ois. 7 plus 1 is 8. So now we're a little bit trickier. Why? Let's make sure I'm doing the correct one. Oh, what did Mr. H do? And this is why I was checking my work. I didn't do it correctly. I multiplied. And what did I forget to multiply that equation? Well, I forgot to multiply this constant. This is why I say, hey, show these arrows. I didn't do it. Look what happened. So this should be 3. Now this is going to work out a little bit nicer. That's what we wanted. So I divide by 5. X equals 2. Don't just circle your answer, because remember, a solution has to be an ordered pair. 2 comma what? Well, I take this x and I substitute it into the one that I didn't change. So 2 times 2 plus 3y equals 7. Why is it 2 times 2? Because my x is now 2. Leaves me 4 plus 3y equals 7. Subtract 4, subtract 4. 3y equals 3 divided by 3. Y equals 1. Perfect. Should I double check it on a test? Absolutely, you should substitute it in. 2 times 2 is 4, plus 3 is 7. 2 minus 1 is 1. Works. Do you always have to double check it? No, but get used to it. Okay. Elimination. The goal is to eliminate one of the variables. Is this tricky? It's not to me. Could you have trouble? Absolutely. So it's telling you to eliminate the x. It doesn't matter. Okay? It doesn't matter which one you do, but it's the same question again, isn't it? I don't want to do the same question. I'm actually moving on. So I am going to go to a problem set. And I love this one. Okay? So don't worry about 6 right now. So this is the old. We're going to write the new. And we're going to write the solution. I actually like how Engage New York had that set up. So 2x, 4x, y, 3y. It does not matter, but we know that we're going to have to multiply this equation by something. I always like to keep my numbers smaller. So to get 2x to be 4x, I multiply by 2. So I made this mistake on the last example. I need to show all of them. 4x plus 2y equals 50. Bring this one over. 4x plus 3y equals 9. We're going to use the additive inverse because they're both positive. I'm going to show that with the subtract. 4x minus 4x is 0x. We don't have oxes. 2 minus 3 is negative y. 50 minus 9 is 41. Okay, this isn't my answer because I have to divide by negative 1. Y equals negative 41. So I come over here, I put negative 41. Immediately, I put negative 41. From there, I take this and I substitute it into the one that we did not touch. 4x plus 3 times negative 41 equals 9. 4x plus 4x positive times a negative is negative 123 equals 9. Add 123, add 123. I don't have a calculator, so I'm kind of guessing this off the top of my head. That's going to be 132 divided by 4. X goes in 34 times. Nope. 4 goes into 13 3 times. That's 12. Minus 1 is another 12, so that's going to be 33. So that gives me 33, comma, negative 41. Let's see if I'm right. Woohoo! I'm right. Elimination method. We will probably spend a whole day, if not 2, just reviewing systems because you missed out in 8th grade. And I'm not going to let you miss on systems because this is going to be an important part of graphing and what we do for the map test. Elimination. Eliminate one of the variables. It does not matter which. Hooray. Where's my...